Beyond statistics to expected utility. Well, a lot of you know about averages. Maybe it's called the mean, mu, watch out for that kitty, or standard deviation, correlation, covariance, and you think that's going to solve a lot of problems. Turns out, not so much in finance. Here, consider the following. We got 3 different gambles. 10% chance of losing 9 and 90% chance of winning 1. B is the opposite, 10% chance of winning 9, 90% chance of losing 1. And C, half the time you make 3, half the time you lose 3. And here's a graphic. You'll notice the first 2 seem to be mirror opposite versions of each other, and the third one is, well, somewhere in between. And of course we perform some perfunctory statistics. We take the mean average, and sure enough, A, B, and C have an average of 0. Then we look at the variance. That's where you square the differences from the mean, and the variances are the same. And thus the standard deviations are the same. But most people would prefer B, then C, then A. Why? Well, that's because most people hate losing money more than gaining the equivalent amount. We can look at instead what's called the certainty equivalent from the expected utility using logarithms. And sure enough, here's one with an endowment of 100. Here's one with an endowment of 1,000. And we'll also try one with an endowment of 11. The endowment is the amount of money you have to start with. And it turns out, kind of surprisingly, the larger the endowment, the more you're willing to take on risk, and vice versa. The person with only $11 would pay almost a whole dollar to avoid that gamble. Person with $100, maybe a nickel, and person with $1,000 hardly cares at all. Here's the actual program for your edification. And do note that not playing at all is the best of all. With a certainty equivalent equal to the endowment, a discount of 0, and with Dr. C.